Well, good morning, everybody. This is Sunday, February 9th, 2020, and got a real exciting presentation, I think. I mean, it's the things that are exciting to me just kind of don't excite others, but that's part of the equation, right? Yesterday, and talking to one of my YouTube favorites, we were discussing bifilar coils. And one of the things that people miss in the bifilar coil is understanding the load. And the load coil sometimes gets called the primary, and sometimes the primary coil needs to be flipped around. And I'm going to discuss why and how that works, and hopefully enlighten you the way my mind works. And so bear with me. What most people call the primary coil in the horizontal plane is that winding, okay? And it's just like a record. And how many windings are in that record is stereophonic, okay? It can be monaural, stereophonic, and then it can also be with the different depths in it, it can be quadraphonic. And then you can just keep right on going through 8 tracks and whatever. Now, I know a lot of you guys understand records and fidelity and everything, but what I'm going to be discussing with you is the first 3 wraps of a stereophonic unit and how in relationship of this is just a router, but I'm going to put those two together, and let's pretend that we're building a Tesla coil, okay? And I'm going to make a proposal to you guys. I am not a Tesla guy. I have very little experience in working with the Tesla coil, but I have a lot of experience working with electricity and loads. And as I keep doing my work and experiments, I'm finding that whenever we put steel or iron into the equation, that iron becomes a load, okay? That's just but iron has so many cool things that has to do with memory and hysteresis. So in a lot of the experiments that I'm working with, it's this technology, which I call the L technology, okay? And the understanding the difference in current and understanding the difference in voltage, okay? And what we're going to do is the whole thing in relationship as we're going through the whole thing is understanding, kind of like a golf swing, how that pendulum actually works, okay, in stresses. The body's like a string in itself, and we have a lot of pendulum motion, golfing motions, and so many things there. And the part of this syllabus that I want to impart to you is getting more understanding into the sector vector pulse width modulation. And I believe in duty cycle and everything that the simple bifilar coil in relationship with what we know as the Bedini circuit can be modified to give us single phase power as a controller and also 3-phase power as a controller. And then, well, I know it is that yesterday I gave you the parameters I use, and I need to back up and explain one thing. When you have your amperage side. And the amperage side is the work being done, okay? That's the work being done. But in the 12-volt system, I showed on the graph that in 5 batteries in series, this being the series side, okay, that I have 5 batteries there. And this battery is a winner, but it's a loser, okay, in the way that I showed the configuration. And I always show 5 batteries there because 5 times 12 is 60, right? I mean, it's simple math. However, you have this 12 volts that you're dealing with on this side. And as that interchanges in the voltage, you actually have 72 volts that's within the system that's passing back and forth, that pulses and keeping that energy moving, okay? So that's why the ratio remains the same in that, and it works the same when you step it up to 24 volts, and then you step it up to 36 volts, and then when you step it up to 48 volts. And so the parameters that you're actually dealing with, and I'm going to explain this page just a little bit more, is that your pressure in those parameters are, when you have that pressurized mode on your work side, that being the work done on that side, you have a working range. And as long as you stay within that working range with batteries and not run them all the way down. Now, lithium ion's a little bit different, okay, but I'm talking about alkaline technology, and I'm also talking about lead acid technology, okay? So wanted to make that clear that when you start getting to the discharge phases, your system is running down. And just wanted to give you the keys of understanding the ratio in voltages and what you're doing with your primary battery pack. So and we're not even talking about the asymmetrical side of the MoGen yet. We're just strictly talking about the Bedini and the system and the way it works, and why that really needs to be looked at a whole lot more as far as battery charging. It's not rocket science, okay? But we do have to flip those things upside down. And again, the Bedini circuit, and like I said, whether it's a 12-volt circuit, whether it's a 24-volt system, 36 or 48, you have parameters that you're working with. And I drew that up yesterday. And again, we're going to talk a little bit about the magnets and parameters. I'm just going to touch on that today. And this is, I haven't got it completely drawn out yet, but I'm working out the slide rule parameters. This is 180 degrees of how all those magnets, 9 on this side, 9 on this side, and what division I need to create the size wheel to deal with the size, and making my slide rule to where I don't have to think about this ever again as far as doing calculation. I can put the ratio in there and automatically know by with the use of a compass of how big in diameter do I need to make a wheel where I have enough clearances when I get down to the towards the shaft, if you will, where I have enough meat of metal to build my system. Okay, and so the whole thing works. If you work too small, then you're locked within parameters on that size wheel. Okay, of course, when you go to a macro wheel, a lot of different things are possible. But I'm still working with wheels that are just, you know, in different dimensions in tooling up for this. Now, just a brief understanding of parametric divisional, and I'm doing a chart with the different magnets up to 9 and all the different variations that you would have in each one of those configurations. Most of us work with the D1 dimension and then the D1.5 dimension and never really get into the D2 dimension. D2 actually starts with 3 magnets. Okay, these are representing the bar magnets in different configurations. So the this all stuck together like that with a that's the north face because that's attracted to the south. Okay, so that's the north face of the magnet. So when you flip that over in the configuration, provided I had a wheel big enough to do it, and you put that magnet, you've pressurized that load by forcing that together, and you're changing that field up. Okay, if you do just one magnet, that's a dimension of parametric oscillation that you've already got preloaded in your magnet set. Okay, in the same set, if I take 3 of those magnets and flip that over, all right, I've got another preloaded system. Okay, and so you can do that all the way through the system on that, depending on the loads in a 9 magnet system. Now, if you go with a 9 magnet wheel system, parametrically balanced by physical weight, the only difference is that you're building a dynamo. And in the 9 system, you have a choice of being 4 and 5. So you take the 4 and 5 and you push those together on the wheel. All right, you change the field up parametrically. Okay, and so there's different schemes that you can do with that. But if you do a 9 magnet wheel, you need to have your coil 12 magnets. You need that third to absorb that bump, just like a Tesla coil. Okay, so instead of width and everything, and I like the rectangular setup because that gets you into root mean square equations as you're working with your different modalities in this asymmetrical fashion. So I hope variation is included in the scale. Now, we can use plastic and to work with a different type dipole, and we can use aluminum. And then also the spacing and time differences, we can do 50% duty cycle by that spacing, or we can have longer duty cycles to how much do we want to saturate that coil. In the old days, they did that actually with commutators, okay? And so they could change up their commutators, keep their same rotor, and they could space their commutators different. Also, they could space the brushes different. They could use a wider brush to make more contact or a lesser brush, and they could time the whole thing in different geometries, okay? And to do that. And most people don't see that. In generators, were actually, they'd find the 0 point of the generator, okay, for potential, and then move their voltage regulation that would handle within that system by the brushes and commutators and different things. So the MoGen is not something I invented. It's like I told everybody, I did a lot of research and understanding the Lockridge device, and the story is that 2 American soldiers at the end of World War II walked into a German barn, and this emergency motor generator was working. The only thing is it didn't have very much battery for the drive that it was doing. It was about 800 watts the way that that was configured. And then in the 60s, converted Volkswagen generators. The Volkswagen generator showed up as 400 watt units. And I did the research and unlocked the keys to figure out what that thing, how that works. And with the help of doing research, found the keys to unlock what I call the MoGen and built that up for my 1.5 kW unit that I've been using for a while as a swimming pool pad pump system. And it works pretty well, you know. And so the foundation, as far as that, I'm making improvements to the manufacturing where it can be professionally manufactured. I have a lot of history in writing manufacturing specs, and the foundation will be licensing that manufacturing specification to be reviewed. And then, of course, that'll be reviewed. It's a whole team that makes that happen. So I'm just part of that team. But I wanted you to understand the parametric dimensional resource, and that's open source, and understanding that you can parametrically balance imbalance in the asymmetrical fashion of how that works. And I'm so glad that I'm able to now talk more about it on the open source side of it. As most of you know, I'm not interested in selling anything, machining anything. I just, you know, this is open source, and just want to share my journey of what I've had with it. The research is out there for free. I can't just put the whole thing out there and show you exactly what I'm doing in the manufactured version of it, but I can show you the parameters of what I can show you of how to get there. So you guys that are really sharp are probably getting a very, very crystal clear idea, you know, that the system, how the system works. Okay. Stored energy does not like to just stay stored. Over time, it'll leak out. Stored energy likes to be pressurized, and if you pressurize it within the design parameters of the way that it was designed, it'll produce energy for a very long time, higher Q factors. I'm sure the battery world knows about this, and I'm sure the electrical world knows about this, and all you're doing is extending run times for a very long time. There is no secret. You have to have the right size of equipment to start off with to make this process. And one of the things that's real surprising when you really go to American United States homes with air conditioning and heating, depending on the size of your dwelling, it still takes an investment. Good equipment, and I haven't found the shortcuts to get there, guys. So sorry if you're looking for free energy. I'm not your guy. I've never seen free energy demonstrated. I have seen high Q factors demonstrated, and again, it's not rocket science, but the advantage that you get with the asymmetrical metronomic system, you can tap in to the electrical quantums, and it's just like pumping water. And that's what I'm going to try to feed into this. Hey, Vinny, good to see you, my friend. I'm going to try to tap into this, and this is called flipping to a load coil. And I'm going to give you the whole notes to flipping to a load coil of what that is and what that means, and hope you guys can see that to the way that works. Now, looking at this coil right here, the flat pancake coil. And again, going back to the that's a coil just like a record, and this is 2 tracks, and I drew it to where there's just 3 coils right next to each other, and I call the innermost one L1, the outermost one L2, and that variance in voltage is actually 1 volt as you're wrapping the coil. However, you have a square root function that happens. So let's say that there's 1 volt difference in the system from your coil, your hollow core coil in this configuration. Okay, so here's your Tesla type hollow core coil going to what we call the primary, and what we're going to do is, like I said, we're going to flip that upside down and see why. Okay, and a lot of people hear me use the word quantum fluid, and I use the term quantum fluid instead of using the ether. Okay, and the ether to me is truly unlimited. Okay. However, when dealing with quantum fluid, you only have so much quantum fluid that you're dealing with in chemistry. Okay, so there's a whole lot of potential as guys are out there that's working with chemistry and working with the elements of doing those things. And one of the things that I've discovered is that you can build a battery in plain sight that looks like the normal things that you would normally use. However, with polymers and things, you can mix polymers up to be a solid, but yet you've got your electrolyte and everything working within that same polymer solution. And Dr. Robert Murray has been doing a lot of work in that field, and we're actually printing batteries, and that can be used along with other polymers, electrolytes, known chemistry sets to produce, battery storage devices. Okay, and so we're still infants when it comes to that. So anyway, the root mean square on that, if we get a delivery from our bounce of our Tesla, the potential between here and this being neutral would be 3 volts if we have 1 volt input, right? Okay. However, because of the drawing around that 3 volts is now 6 volts. It's doubled. Can you see that? We do have 3 volts to here. We do have 3 volts to here, but when we go across here, we've squared it, and that's the voltage. The other thing is understanding heavy to light and light to heavy. And what I mean by mass and weight in different things, there's more than one way to skin a cat. And the way to skin that cat, and I'm going to flip this around very carefully to where, let's pretend that this is a water pumping system. Okay. And we're looking at the ground underneath the water. We're looking at the ground to it. That can be, and then we're looking at the atmosphere or the construct we're living in. Okay. And we can learn by flipping that around different ways to make our construct work for us. Okay. And that's what you're doing, is that once you flip it upside down and get a visual reference to what you're pumping and pumping the quantum fluid, you start to see different ways. Okay. So if you flipped it upside down, you could actually pump this with air, couldn't you? Okay. So you can actually put divisions of air, make your bubbler, and actually create a pumping system to make that work. But understanding the different elements that you can use to flip that around and make this construct and its secrets do usable work for you, and do that in a slide rule type fashion. And so what's Brohamshire? Jason, I don't know the answer to that one yet. Don't know the answer to that one yet. If it's the same line that we're working with different things, it does come back to the space vector pulse width modulations. And I guess we're all brohams. Yeah, we're the brohams. Okay, you had me on that. Hey, my fellow brohams. Yeah, you guys are my brohams. I love you guys tremendously, and I enjoy talking to you. I enjoy learning everything that you guys have taught me. And like I said, a lot of videos when I started doing this, posting videos a year ago, I said, I got a lot to offer the community, but Roy, I watched you so much through the years, you don't even have any idea. Before I even made contact with you, I go, that guy is sharp. And just watching you, I got so many good ideas. So yeah, we're three amigos, and Scott Russell's in there too, and so is Gerard Morin with this whole thing. So anyway, I hope this helps you. Hope this is informative to you. But I want you to view the different ways the system works for you, and to do that, I flip it around and I keep flipping it, and I discover that tension of how that works, and how we can get to discover the secrets that were part of our society, and we're just now getting woke up that we don't know our history, and it's very obvious from the Tartarian Empire and different things in that. And we're having to relearn things that we didn't know before. So let's see. Yes, very much so. Almost feel like this video was made for me. Hey, it was made for you, Roy. It was made from our discussion yesterday. I'm not a mental giant. Okay. For me to research something, this skull right here is very, very dense. But once I get the slide rule parameters, okay, once I can pull that out and know where to set that sucker, it's just like steamer gauges on an airplane. All I need is the numbers, and I'm gone. Okay, I know which direction I'm going, how to follow the magnetic compass, and interpolate all the instruments to get me to where I'm going to go. And of course, with aviation, the only kind of trip that I like is an uneventful trip. So I love to see the scenery and love to fly, but flying to me is boring. That's the reason I never wanted. I love teaching it. Love teaching aviation. I love teaching ground schools. I also love teaching acrobatics. But as far as just flying a commercial plane from one place to the next, after a few hours, believe it or not, I'm just bored out of my mind. And I wanted to rethink that, because there's times that I really wanted to be bored because I was having a very eventful trip. But let's see, I'm going to have some cool stuff to share at the end of the week. You guys are going to love it. 1200 volt high frequency on the smart drive. Yeah, buddy. Yeah, buddy. Bring it on, Jason. Bring it. So anyway, I am a good researcher, and I do enjoy researching. I'm pretty hands-on. I can build boats from the ground up. I built plugs and models and stuff up. But now the aircraft that I'm going to build is completely different, and I need dependable 15 kW for 6 hours, and I know I can do it now. The only thing is I got to size it down to where it works, and it's going to take some ingenuity to get it done. So you guys are my three amigos working with me. I follow you, and you guys have helped me a whole lot. And Jason, your work is just freaking awesome, and so is yours, Roy. I'm going to sign off for now, and hope you guys have a wonderful day, and I'll see you next time. I know you guys are having fun because we are. Yeah. Bye for now, and I'll see you next trip. Love you guys.